Hey everyone, welcome back to Math with Vanch. I'm Vanch and I'll be teaching you math, obviously. So now in the last video we looked at chain rule, and in this video we're going to look at implicit differentiation. Now implicit differentiation is basically another application of the chain rule, so it's kind of fitting to do it after, So yeah, if you're ready, I am too. Let's get started. Okay, so implicit differentiation basically has to do with functions that have both an x and a y in them. Right, so for example, a function like this would be like a circle function. For example, we know that the formula of the unit circle is just going to be x squared plus y squared equals 1, right? I'm going to write that bigger. X squared plus y squared equals 1. Okay? So this is just the formula of the unit circle, which we all know, right? What if we wanted to find the slope at any given point on that unit circle? So like if we had a point on the unit circle and we wanted to find the slope of the tangent line to that point, and how would we do that? Well, obviously in a regular function we would just take the derivative, right? But we can't do that here because we have a y squared term right there. So what do we do? So here we can apply implicit differentiation. So basically the first step is to differentiate both sides, and we can do this because whatever you do to the one side of the equation, you can also do it to the other side of the equation, right? So we can do d over dx of x squared plus y squared equals d dx of 1. Now we can split this up into d dx x squared plus d dx of y squared equals d dx of 1. We know that's just going to be 0, right? Because the derivative of any constant is just going to be 0. So equals 0. Now this one's easy. We can just do power rule right here. So that's just going to be 2x. But how do we do this, right? So the derivative of y squared. So how can we go about that? So what we can do is we can actually think of y as a function of x, right? So if we thought of y as, suppose y of x, right? And then we took the derivative of y of x squared, which is basically what this is. So we have the derivative of y of x squared. So now what we can do, we can just apply chain rule to this, right? Because it's a function inside of a function. So we know that our outside function in this case, our outside function is going to be x squared because it's something squared, right? And our inside function is going to be y to the x. Y of x. So we take the derivative of the outside with respect to the inside, right? So 2x, but instead of x, we're going to have y to the y of x. And then multiply that by the derivative of the inside function. Now the derivative of the inside function is just going to be y prime of x, right? Same thing. So now what we can do, actually I'm going to write this as d over dx of that. That might be a bit easier. So now what we can do, we can change the y of x back to just regular y. So we can do 2y times, and then d over dx of y. And this basically this is kind of weird thing to do, but what you can do is put the y up here and make this a 2y times dy over dx. And this is something you can do with the derivative operator. And dy over dx is going to be the slope that you're solving for. And that's going to make a lot more sense when you plug it back into here. So let's do that now. So we just found the derivative of this part, which is going to be 2y times dy over dx, and that equals 0, right? And we know that this is the thing that we're solving for, right? Dy over dx, that's the slope of the function. So let's solve for that. So we can subtract 2x from both sides. So 2y dy over dx equals negative 2x. And then we can divide both sides by 2y. So dy dx equals negative 2x over 2y. The 2's cancel out, so then dy over dx equals negative x over y. So this is going to be the equation for the slope at any given point for this function right here. So suppose on the unit circle we know we have the point root 2 over 2 comma root 2 over 2. So if we wanted to find the slope at that point, then we can just plug it into this equation and then we'd get the slope. In this case, we know that it would be root 2 over 2 divided by root 2 over 2, which is just 1, and then the negative of that, so that's just going to be negative 1. So yeah, that's implicit differentiation. Okay, so let's look at another example. So we have x plus y squared equals x minus y plus 1. Okay, so this is a graph. I don't quite know what it looks like, but it's a graph, trust me. So what if we wanted to find the slope at any given point of this graph? So easy, we can just do implicit differentiation on this, right? So take the derivative of both sides. And then the other side too. And now we can evaluate this, right? So this is a chain rule problem. The outside function in this case is x squared. So we're going to drop the 2 down. So we're going to have 2 times x plus y, and then multiplied by the derivative of the inside part. So the derivative of x plus y, derivative of x is just going to be 1, plus y. So derivative of y, as we saw before, is going to be dy over dx, right? So dy over dx. And that equals the derivative of this side. So derivative of x is just 1, minus derivative of y is going to be dy dx. And then the derivative of 1 is just 0. Okay? So now, since we want to find slope, we want to solve for dy over dx. So what we have to do is we have to get all the dy dx terms on one side. So let's do that. So first I'm going to distribute this 2n. So we're going to have 2x plus 2y times 1 plus dy over dx equals 1 minus dy over dx. And then I'm going to FOIL this whole thing out. So we're going to get 2x plus 2y, and then plus 2x dy over dx plus 2y dy over dx. And then that's going to equal 1 minus dy over dx. And now we just want to get all the dy dx terms on one side and then all the other terms on the other side. Okay, so we already have 2 of these. We'll just get this one over by adding to it. So 2x dy over dx plus 2y dy over dx, and then plus dy over dx. And then we're going to move all the other terms to the other side. So we're going to subtract by 2x and subtract by 2y. So we're going to be 1 minus 2x and then minus 2y. Okay? Now we can factor out a dy over dx on this side. So get 2x plus 2y plus 1 equals 1 minus 2x minus 2y. And finally, we can divide this part out. So we divide both sides of the equation just by this part. So our final answer, our slope is going to be 1 minus 2x minus 2y all over 2x plus 2y plus 1. That's our answer. So yeah, that's implicit differentiation. So that's going to be all for this video. As we saw, implicit differentiation is basically just another application of chain rule, and it kind of makes those functions with a bunch of y's and x's in them a lot easier. Now again, if you have just regular functions with only x in them, then obviously just use regular differentiation. But once you get into that y territory, you can use implicit differentiation and it'll make your life a whole lot easier. So anyways, that's all for this video. I hope you found it helpful, and if you have any feedback, please let me know in the comments. Otherwise, I'll see you for the next one. Bye bye.